We are going to take a look at direct, joint, and inverse variation. Direct variation is always in the form of y equaling k times a number. So basically, if x gets bigger, then y gets bigger. If x gets smaller, gets smaller. What one does, the other does. So that's direct variation. The k here is referred to as your constant of variation. No matter what you're dealing with for variation problems, you will always have a k value there for your constant of variation. So an inverse, basically, if x gets bigger, you'd be dividing by a bigger number, causing y to get smaller. So x gets bigger, y gets smaller. Or vice versa. If x gets smaller, y gets bigger. So what one does, the other does kind of the opposite. Those are referred to as inverse variations. With an inverse variation, your variable of x will always be in the bottom of the fraction with your constant of variation on top. We also have joint variation. Joint, you have more than, it's a direct variation, so it's like y equals kx, but instead of just having an x over there, you have more than one variable. So another way to look at it is with direct, you're always having a variable multiplied by a number, and that number would be your constant of variation. With inverse, you always have a variable being divided by a number divided by a variable. And that number, once again, is your variable or constant of variation. And then with joint, you have a number multiplied by a couple of variables, where that number is your constant of variation. So let's go ahead and decide which one's which here. Our first one, we have a equaling to a number times two variables, so that we should know that that is going to be our joint, with our constant of variation then being our 5. Now, here in the middle, we have our variables multiplied together equaling another number. Well, we need to have one of the variables by themselves, so I'm going to divide both sides by v. You'll now notice I have a number divided by a variable. So that means that would be an inverse. That number would be your constant of variation. Now here, you'll notice I have a number divided by, or a variable divided by 4. I could write that as a 1 over 4 times a is equal to b. You'll now notice I have my b by itself. I have my a being multiplied by a number. So whenever you have your variable being multiplied by a number, then you know that that is a direct variation. So our constant of variation would be a 1/4. So let's go ahead and work this out. We have y varies directly to x. So I'm going to go y is equal to, then throw in my constant of variation of x. We also know that x and y here, so I'm going to plug in my y, plug in my x, and that allows me to find k. When I divide to find k, I end up getting 1.2. Now, if you wanted to write that as a fraction of 6 over 5, you'd be welcome to. So then I'm going to go ahead and rewrite my general equation with my constant of variation. Now I can go ahead and find y with this value of x. Plug in my x, multiply that out, and I get y then to be 24. All our variation problems are going to be very similar, but here we're starting out with an inverse, so remember I need to then divide by my variable of x. I'm going to then go ahead and plug in the information I have so that it can help me find my k value, my constant of variation. And then in this case, I get k to be equal to negative 168. Then you want to rewrite your original general equation with that value of k plugged in. And then you can go ahead and answer your question. Here we're trying to find x. So you'll notice x is in the bottom, so I'm going to multiply both sides by x to get x out of the bottom, because on the right, timesing by x cancels out the dividing by x, leaving us with negative 168 equaling a 21x. Then to get x totally by itself, all I'd have to do is do some dividing, and I get x to be equal to a negative 8. Here we have a joint situation. So I'm going to go y equals my constant of variation with my two letters of x and z. Then I need to find the three things that go together, which are these here. Plug those in. My y is 80. My x is 5. My z is 8. So I get 80 is really equal to 40 times k. Solve it for k, and I get k to be equal to 2. So I'm going to rewrite my original general equation with that value of k plugged in there. Then I can actually plug in the stuff to answer my question. I need to find y, plug in my x, plug in my z, and I get y to be 64. Now, sometimes you'll be doing all this, but it'll be given to you with lots of words. Still, same idea, volume varies inversely to pressure. So I go V equals my constant variation. Because it's inverse, I know that P is going to be in the bottom. So now I'm given my volume and my pressure. Plugging in my volume and my pressure allows me to find the value of K. To get K by itself, I'd have to multiply both sides by that 2500, because right now I have k divided by that. Remember, I have to do inverse operations, and so I get k to be this. Write out your general equation with that value of k plugged in there, and then we can go ahead and answer our question. We need to find v when p is this. And we get 625. We were looking for volume. Now you'll notice in your problem here, volume is in cubic centimeters, so I'm going to have to go centimeters cubed.